This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the chain rule. So here's our formal definition of the chain rule. The derivative of f of g of x is f prime of g of x times g prime of x. So let's see how that behaves. We'll compare that to our work with the power rule. So our power rule tells us that the derivative with respect of x to the n is nx to the n minus 1. Now with the chain rule, the derivative of f of x to the n is n times f of x to the n minus 1 times the derivative of f of x. And I prefer to leave the f of x out. So I'll say the derivative of something to the n is n times something to the n minus 1 times the derivative of the something. So let's look at the following example. We want the derivative with respect to x of 5x cubed plus 4x squared plus 7x plus 3 to the 13th power. So I see that is the derivative of something to the 13th power. So using our power rule, that's 13 times something to the 12 times the derivative of the something. The something, of course, is 5x cubed plus 4x squared plus 7x plus 3. And what is that derivative of 5x cubed plus 4x squared plus 7x plus 3? That would be 15x squared plus 8x plus 7. And then there's really only one more thing you can do. You can multiply that 13 by 15, 130, 50, 180, 195, x squared. 13 times 8, 80 and 24, 104x. 13 times 7, 70, and 21, 91. So indeed, distributing the 13 times 15, 13 times 8, 13 times 7, we can get a slightly simplified version of this written that way. Of course, you would never multiply this out to the 12th power because that would be a remarkably tedious process. Our next example is the derivative with respect to x of the square root of 5x squared plus 4x plus 9. We're thinking power rule, so we need to rewrite the square root as to a power, and of course that is to the 1/2 power. And that becomes the derivative with respect to x of 5x squared plus 4x plus 9 to the 1/2. Pull the 1/2 down, it'll be 1/2 times the something to the negative 1/2 times the derivative of the something. But what is our something? Our something is 5x squared plus 4x plus 9. And the derivative of 5x squared plus 4x plus 9 is 10x plus 4. So we get 1/2 times all of this to the negative 1/2 times 10x plus 4. Now the negative 1/2 power means 1 over that to the positive 1/2 power, or 1 over the square root of that. And we'll also have to do some algebraic simplification with the 1/2 and the 10x plus 4. So indeed, there's the 1/2. 5x squared plus 4x plus 9 to the negative 1/2 is 1 over the square root of 5x squared plus 4x plus 9, 10x plus 4, 10x plus 4 over 1. And I will be able to reduce this fraction because I can factor a 2 out of the numerator and factor a 2 out of the denominator and divide those out. Factoring the 2 out of the numerator, that would give me 2 times 5x plus 2. And with the 2 in the denominator, dividing numerator and denominator by 2, my final answer will be 5x plus 2 over the square root of 5x squared plus 4x plus 9. Our next example with the chain rule as an extension of the power rule is the derivative of 1 over x squared plus 5 to the 9th power. But I want to write this as an exponent. So 1 over x squared plus 5 to the 9 is the same as x squared plus 5 to the negative 9 power. So we've got to think about how this is going to work. We're going to pull the exponent down. Negative 9 times the something to the negative 10, when we decrease that exponent by 1, times the derivative of the something. And the something in this case is x squared plus 5. So it'll be negative 9 x squared plus 5 to the negative 10 times the derivative of x squared plus 5. And the derivative of x squared plus 5 is just 2x. And then all we've got to do is multiply negative 9 times 2x to give me negative 18x. Recognizing x squared plus 5 to the negative 10 is 1 over x squared plus 5 to the 10th power. And putting all that together, we get negative 18x over x squared plus 5 to the 10th power. Next, we're going to take a look at the chain rule as an extension of the e to the x function, the exponential function, we know the derivative of e to the x is e to the x. So the derivative of e to the f of x is e to the f of x times the derivative of that f of x. I want to think of it as the derivative of e to the something is e to the something times the derivative of the something. So what I have here is the derivative of e to the 5x plus 3. Again, derivative of e to the something is e to the something times the derivative of the something. So it'll be e to the 5x plus 3 equals e to the 5x plus 3 times the derivative of 5x plus 3. And what is the derivative of 5x plus 3? Just 5. So we get e to the 5x plus 3 times 5, written typically with the 5 first, 5 times e to the 5x plus 3. Our next example, similar sort of thing, is the derivative of e to the x squared plus 9. The derivative of e to the something is e to the something times the derivative of the something. The something is x squared plus 9, so the derivative of e to the x squared plus 9 will be e to the x squared plus 9 times the derivative of x squared plus 9. And what is the derivative of x squared plus 9? That's 2x. So we get e to the x squared plus 9 times 2x, typically written as 2x times e to the x squared plus 9. Now we're going to extend the logarithmic functions into the chain rule. So the derivative of the natural log of x is 1 over x. We're interested in the derivative of the natural log of a function. So the derivative of a natural log of a function is 1 over that function times the derivative of the function. And I like to use empty parentheses or brackets to think of it as the derivative of the log of something is 1 over the something times the derivative of the something. That's our basic idea of the chain rule for logarithmic functions. So if I want the derivative of the natural log of 3x squared plus 5x plus 9, I think of the derivative of the natural log of something as 1 over the something times the derivative of the something. So 1 over 3x squared plus 5x plus 9 times the derivative of 3x squared plus 5x plus 9. And what is the derivative of 3x squared plus 5x plus 9? That would be 6x plus 5. So 1 over 3x squared plus 5x plus 9 times 6x plus 5 over 1 just gives me 6x plus 5 over 3x squared plus 5x plus 9. Our next example is the derivative of the natural log of x to the 10th. So again, we're going to use our rule. The derivative of the log of something is 1 over the something times the derivative of the something. The something in this case is x to the 10th power. So the derivative of the log of x to the 10th is 1 over x to the 10th times the derivative with respect to x of x to the 10th. The derivative with respect to x of x to the 10th would be 10x to the 9th. So what does that look like? We have 1 over x to the 10th times 10x to the 9th. And x to the 9th divided by x to the 10th would just leave me with an x downstairs, so that my final answer would become 10 over x. Now, there's another way we could have done this. We recognize that the log of x to the 10th can be simplified using one of our rules of logarithms. So let's take a look at that. We're interested in the derivative with respect to x of the natural log of x to the 10th. But our rule is that the log of x to the p, you can pull the exponent down, that's just p times the log of x. That's true for any base. I'm just using natural log here since that's what's in our example. So I can rethink of log x to the 10th as 10 times log x. So if I want the derivative of the natural log of x to the 10th, that's the same thing as the derivative with respect to x of 10 times the natural log of x. At this point, we can go ahead and pull that 10 out. So that would be 10 times the derivative with respect to x of log x. And what is the derivative with respect to x of log x? That, of course, is just 1 over x. So we get 10 times 1 over x. 10 times 1 over x is 10 over x. And we're quite pleased with that because our original problem done using the other strategy also gave us the answer of 10 over x. So to recap the lesson, the formal chain rule tells us the derivative with respect to x of f of g of x is f prime of g of x times g prime of x. Take the derivative of the outside function, apply it to the inside function, multiply the derivative of the inside function. When we looked at the power rule, the derivative of something to the n is n times something to the n minus 1 times the derivative of the something. When we examine the derivative of e to the something, Using this rule, that was e to the something times the derivative of the something. And our last rule was the derivative of the natural log of something, 1 over the something, following this rule, times the derivative of that something. And that will conclude this lesson.